Okay, so let's look here. 4 times 0 is 0. Sine of 0 is 0, so we get 1. Now cotangent. Cotangent is 1 over tangent. So if I'm approaching 0 from above, that means my rays are moving in this direction. Okay. My tangent is approaching, well, let's write it out. So as my angle measure approaches 0 from above, these slopes, right, the tangent is approaching 0. So then 1 over tangent, which is the cotangent, we're dividing by something that's shrinking. So 1 over tiny is approaching infinity. So here we have the indeterminate form of 1 to the infinity. So that's going to be tricky, right? We can't directly compute this limit. We have to do some maneuvering. So we're going to start by saying this limit that we care about. I'm just going to give it a name. We're going to call it L. Now we're going to take the natural log of both sides so that we can bring this exponent down. Since the function natural log is continuous, we're able to flip-flop this and this. Bring this natural log in here. Okay. So now we can bring that cotangent down. Times natural log of this. There we go. So the cotangent we can write as 1 over tangent, so that this inside expression here is natural log of this divided by tangent. And so if we plug in 0, right, thinking about our limit, then we have natural log of 1 plus, okay, sine of 0 is 0, 1 plus 0 is 1, natural log of 1 means e to which power is 1, that's 0. So natural log of 1 on the top over tangent of 0. The slope of this ray right here has a slope of 0, so that's going to be 0. So we have 0 over 0. So that allows us to use L'Hopital's rule. But that confirmation is essential before moving on, right? You can't use a rule if the like conditions of the rule are not met. So we have to show that we have an indeterminate form of 0 over 0 or infinity over infinity. So by L'Hopital's rule, we can now find the quotient of the derivatives. So let's look just at the top. So we're going to have 1 over 1 plus sine of 4x times the derivative of the inside, which is 4 cosine of 4x. And on the bottom, we will have secant squared. So let's look at this separately. So we have 4 cosine of 4x over 1 plus sine of 4x divided by secant squared. So I'm just writing it out super carefully so we can understand the fractions going on. So that's the same thing as multiplying by 1 over secant squared. And 1 over secant is cosine. 1 over secant is cosine. All right. So now let's examine this limit. So let's put the limit notation back. And let's sketch our unit circle for reference. And we're looking right here at 0. At this point, 1 comma 0. Okay, cosine of 0 is 1, so that's going to be 1 squared, which is 1. Sine of 0 is 0, so the denominator here becomes 1. 4 times 0 is 0, so then cosine of 0 is 1. So we have 4 over 1 times 1. The answer is 4. And we are not done, because this was equal on the left to natural log of L. Remember, we started by, we gave this number a name, we called it L, and then we took the natural log of both sides. So what we know is natural log of L is 4. So this is saying the number of factors of E in this number L is 4. Or you can think of it as the exponent I have to put on E to get L is 4. So that means L is E to the 4th. And this is my final answer. So this limit up here equals E to the 4th. And that's, kind of one indication that E is the natural number. It has shown up in this random place with trigonometry, but there it is. It's all over the place. It is a number that comes from nature.